Okay, so here we want to compute the derivatives of these, and again, I would not use a quotient rule here. I would just rewrite this as 3x plus 7 to the negative 5, and then I would differentiate using chain rule, where this is the inner function right here, and it's u to the negative 5. So what's the derivative? Negative 5 times u, which is 3x plus 7, times the derivative of u, which is just 3. Oh, negative, and don't forget minus 6, right? And then you're going to get negative 15, 3x plus 7 to the negative 6. And you can leave your answer like this. The next one, similarly, I would also, if I were looking for the derivative, I would write it as x to the 5th plus sine x to the 1/2. And I would differentiate this using chain rule. I would say that this whole thing is u. I'd bring down a 1/2, right? The g stays the same, x to the 5th plus sine x to the negative 1/2 times the derivative of this whole thing is going to be 5x to the 4th plus cosine x. And you could leave it like that. That's fine. That's okay. Now for going forward, we've got, let's see. And let's see the next one. Okay, so C we have. Okay, and this is a good one because it involves a rule within a rule, and those are always tricky, times cosine x. Okay, so what is this one firstly? This is first and foremost a product. It's this function times this one. So since it's a product, you want to remember product rule. The derivative of f times g is the derivative of f times g plus the derivative of g times f. So what takes the role of f here? This function, and then this takes the role of g. So what's going to be the derivative? The derivative is going to be, the derivative of this whole thing is going to be the derivative of this. So let's write it out without doing any work, just maybe for good bookkeeping, right? It's going to be the derivative of this times cosine x plus the derivative of cosine x. I could write that. That's easy. That's negative sine x times f, which is sine of log of x. Now, the thing that's still not done is this one here. You need to find the derivative of that. You can't leave it as saying that you're going to find the derivative. So you need to find the derivative of that. And I personally would really take it on the side and just be like, okay, well, what's happening here? And then I would just substitute it in on the next line over there. So this here, we need to look at this as chain rule, where this is the inner function. That's like u. What's the derivative of sine u? Cosine u times the derivative of u. But what takes the role of u? And what's happening here? What's taking the role? Log x is taking the role of u, right? So times the derivative of log x, which is 1 over x. And now I have this derivative. Now I plug it into here. I'm going to get cosine of log x over x, because that's 1 over x, times cosine x plus, or I should put minus, just to get rid of that, make it a little bit prettier, minus sine x times sine log x. And this is really as simple as it can get. Don't try and combine anything. Make sure you know that cosine of theta times cosine of x isn't cosine squared of anything, right? This is some other variable. Cosine x times cosine x is cosine squared x, right? But cosine log x times cosine x, that's all you can do. You can't multiply those two. Similarly with the sine x and the sine log x. Okay, now the next one. Let's do this all in one video. So now the next one says, so let's give myself some space. The next one says the square root of e to the x plus the square root of x. And again, you want to find the derivative. I would rewrite everything as powers. So I would say that this is equal to e to the x plus x to the 1/2 to the 1/2. And then I would find the derivative of this. How do I find the derivative of this? This is u, and I gotta use chain rule. That whole thing that I just boxed is u. The derivative of u to the 1/2 is equal to 1/2 u, which in this case is e to the x plus x to the 1/2. To the negative 1/2, when I minus 1 from the exponent, is 1/2 u to the negative 1/2 times the derivative of this. The derivative of that inside is e to the x plus, right, 1/2 x to the negative 1/2. Okay, so let's make it look a little bit more organized. So times, right, so times this bottom part, the derivative of this. The derivative of e to the x is just e to the x plus the 1/2 comes down. The derivative of x to the 1/2 is 1/2 x to the negative 1/2. And then this is your final answer. Know that this is saying times this one, right? Not divided, because now I drew that line there. But yeah, it's saying this times this here. And then that's it for that one. Okay, now let's see if I can keep going. Just bear with me. Let's have another one here. And let's see, let's write down all the ones that are left. It's ax e to the negative bx, and then it's e to the negative x to the 6th. Okay, so the derivative of this, right, just know that that a is some constant, so it's a times the derivative of this, because you could always pull out the constants. And then now your trick is that you got to find the derivative of that. The derivative of this you need to see as primarily as a product. This is f, and then this whole thing is g, right? And then what is the derivative? It's f, the derivative of f, sorry, it's f prime, right? What's the derivative? F prime times g plus g prime times f. So just have that, right? The derivative of f is 1 times g. G is e to the negative bx plus the derivative of g, that you might want to take your time with, e to the negative bx. This whole thing is like u. The derivative of e to the u is e to the u times the derivative of u. So it's e to the negative bx times the derivative of negative bx, which is negative b. And then instead of writing plus here, I'll put a minus to make it look a little bit neater, as minus the derivative of e to the negative bx is negative b e to the negative bx, and then times f is just times x. And then this is your final answer, is perfectly fine. Now this one, not too bad. E to the negative x to the 6th. This is like u. The derivative of e to the u is e to the u times u prime. What takes the role of u? E is negative x to the 6th times negative 6x to the 5th. You can rewrite it, make it look a little bit nicer like this. And then that's it. You're done from here.